We are in chapter 10. We're going to now talk about radical expressions. We're going to simplify them. So, a radical expression, you guys would normally say square roots, but we call them radicals because sometimes it's not a square root. Sometimes there's a 3 here or 4, which is called the index. This part is the radical. It's a square root if there's a 2 here, but we don't ever write the 2. Like here, it's assumed this is 2. It's a square root. It's so common that we just don't write it. The x, whatever's underneath, is called the radicand. So we're going to simplify these. Just like it's not okay to leave on your paper a 4 or 2/4, you would write it as 1/2. It's not okay to leave these unsimplified as well. So it says step 1, determine the largest perfect number that divides into the radicand. We write the radicand as a times b, where a represents the value from step 1, and step 3, take the square root of a. So for example, they're saying break down 20 as a square root of 5 times 4, for example. It says take the square root of one of the factors. Well, what's the square root of 4? It's 2. So our answer is 2 square roots of 5. It says write this value as the radical. Leave b on the inside. So that's it. An example of this again could be 75. I know is 3 25s. So 3 times 25. Take the square root of 25. That's 5. So it's 5 root 3. So that's one way to do it. Another way would be to break down the number into prime factors. So 2 times, well, I know 9 times 5, okay, is the same thing. I could take a 3 out like I normally would. The square root of 9 is 3. Or I could just break them down further and say 5 times 3 times 3. Either one's fine. I know this to be the square root of 5 times the square root of 3 times the square root of 3. When I see a pair, the square root of 3 times the square root of 3 is simply just 3. So we have a rule here. The square root of a times the square root of a is just a. So this is just 3. That's why we just take out a pair, and we already have a 2 here, so it's 2 times 3. So it's going to be 6 root 5. So we can do it by taking a square root, or we can break it down completely and take out a pair. Either way is fine. So let's take out a pair here. So 64. Well, I know the square root of 64. The square root of 64 is 8. Or we could have done it this way. The square root of 64 is 8 times 8. I have a pair, take out 1 8, because we're talking about square roots here. Square root of 72 is 9 times 8. You can take out a 9 here and make it 3 root 8, but 8 can be broken down even more to 4 times 2. Take the square root of 4, that's a 2, and it's 6 root 2. Or what you can do is simply break down 108 into as many factors as possible. 2 times 54. And then I know 54 is 9 times 6, and I know 9 is 3 times 3, and I know 6 is 3 times 2. So you could also just take all the prime factors, 2, 2, 3, 3, 3, and take out pairs, a 2 and a 3 and a 3 inside, which leaves you with negative 18 root 3. So let's recap. I can break them down into perfect squares and other numbers. So I could take the square root of 4, which is 2, square root of 25, which is 5, or I could break them down to all prime numbers and take out the pairs. Okay, so that's how you simplify radical functions. We're just dealing with square roots right now. Here, product property of square roots, if they are multiplied underneath the radicand, you can put them together. So this is going to be the square root of 27. But I know, like we just said, this is square root of 9 times 3. The square root of 9 is 3, and we have a 3 inside. Here, same thing. I know the square root of 6 times the square root of 8. Well, 6 is 3 times 2, and 8 is 2 times 2 times 2. I find a pair and I bring it out. I find a pair and I bring it out. Square root of 3. So my answer is 4 root 3. Here, I'm multiplying the whole numbers together. So 3 times negative 2 is negative 6. And square root of 8 times square root of 5 is square root of 40. I could have just broken it down and kept it broken down, though, because we have to simplify this. So this is the same thing as 4 times 10 or 8 times 5. It doesn't matter. Square root of 4 is 2. And my answer is this. Here, 6 times 2 is 12. Square root of 2 times square root of 2 is square root of 4. Well, what's the square root of 4? That is simply a 2. So my answer is 24. Here, I am taking a square root and squaring. They cancel each other out, and my answer is 15. You could even try it in the calculator. Take the square root of 15, and then you square that. Okay, they just undo each other. Here, same thing. I could just put in my calculator, square root of 3. I want you to try it because if you have this on a keystone, you need to know how to do it. Get out of there to the right, close the parentheses, square it, enter. Or you could have done it by hand. This is the same thing as 3 square root of 4 times 3 square root of 4, which is 9 square root of 16. Well, the square root of 16 is 4, so it's 36. Okay, on the back, it says quotient property of square roots. Here, we can take 15 divided by 5, which is 3, and 27 divided by 3, which is 9. What's the square root of 9? 3. So my answer is 9. Here we can do the same thing. 48 divided by 4 is a square root of 12. We can only do what's under the radicand with what's under the radicand. Well, square root of 12 is 4 times 3. The square root of 4 is just 2. So my answer is 6 root 3. Here, 9 over 27 is the same thing as 1. 9 can go into 27 3 times. 50 divided by 2 is the square root of 25. Square root of 25 is 5. So your answer is 5/3. Here, 12 divided by 6 is 2. 72 divided by 9 is 8. When I break 8 down, that is the same thing as 4 times 2. The square root of 4 is 2. So my answer is 4 root 2. Now, these worked out really nice with whole numbers in the denominator or there wasn't a denominator. What if we have one in the denominator? So for example, 2 divided by the square root of 3. If I divide by something that never ends, it just rounds it. It doesn't stop there in real life. The calculator stops it there. It keeps going. So it's not really okay to leave something as divided by a number that never ends. We want to what's called rationalize it. It's currently irrational. So we want to rationalize it and make it rational. To get rid of a square root, we have to square it. So if I multiply it by a square root of 3 on the bottom, I simply get a 3. But I can't change the actual numerical value. I still have to keep it as about this number. I have to keep it 1.154700538. So what I do to the bottom, I do to the top. So I don't actually change the value because the square root of 3 divided by the square root of 3 is simply 1. I'm not changing the value. I'm just giving it a makeover. So this is my answer. So does this answer still give you the same numerical value? Yes. Okay. But this is what the preferred. So same thing here. I want to get rid of the square root of 5. So I multiply the top and the bottom by the square root of 5. And my answer is square root of 35 over 5. Same thing here. If I'm dividing the whole thing, I'm dividing the top by the bottom. I don't like the square root in the denominator, so I rationalize it by multiplying the numerator by the same thing. This is going to be the square root of 12. Can this be broken down? Absolutely. 12 is 4 times 3. Square root of 4 is 2. Okay, so let's recap. I wanted to get the 2 broken apart so that I can rationalize the denominator. I get the square root of 12 over 6. 12 is 4 times 3, and the square root of 4 is 2. 2 can go into 6 3 times. So it's a third. And that is your answer. The beauty of math is you can check your work. Did we do it correctly? Square root of 2 divided by 6 is 0.57. Square root of 3 divided by 3 is the same thing. If it wasn't, we did it wrong. I need to get rid of the square root of 7, so I multiply the numerator and denominator by the square root of 7. I get 2 times 7 now in the denominator. Square root of 7 times square root of 7 is just 7. But can 56 be broken down and simplified? It can. It is the same thing as 8 times 7, which is the same thing as 4 times 2 times 7. The square root of 4 is 2, and 2 times 7 is 14. But I can reduce this and make a 7 in the denominator, and that is my answer. Let's check. The original is square root of 8, enter, divided by 2 square root 7, 0.534. Square root of 14 divided by 7. Same thing. Okay. And that is, we're going to stop here today. No, let's just keep going. Yeah, let's keep going. Yeah, let's keep going. This is probably the largest section, and that's okay. Example 5. Okay, I don't want you to worry about the absolute value bars or anything like that for right now. All I want you to do is simplify. You know what? Yeah, let's make this part 2.